Hello, my name is Pinglin. I'm from Ocean University of China. My research was focusing on bioactive compounds from soft corals and associated fungi collected from the South China Sea. The first work was a collection of soft coral samples from the South China Sea. Last year, we collected soft coral samples from Sanyak Ocean, Hainan Province, in the South China Sea, and more than 150 samples were collected by artificial, and last 80 specimens were identified. The second work was new compound isolation and identification. Using GNPS, molecular networking, and other ways, 285 new structural compounds were discovered, with a novelty rate of nearly 35%, and 17 new skeletal compounds were identified. The new structural molecules mainly include terpenes and alkaloids. Among them, symbiotic bacteria produce abundant and multi-substituted alkaloids. Heteroatomization has become a standard template and technical requirement for structural characterization. The third work was bioactive compounds identification. Using antitumor, cytotoxic, antimicrobial, and zebrafish models, monotronic compounds were found having pharmaceutical study potential. Structural activity accordance with the disease was suggested to have a most interesting study potential. Some more activity assess models are going to be used for the activity study. The fourth work was a structural elucidation technique was investigated. We have independently designed a molecular self-assembly program, PETRO, DUFA based on spectroscopy, which combines molecular mechanical force field and quantum chemical assisted computation (DFT) certain carbon NMR methods to elucidate bugs from various petrol self-assembly programs for small data nodes, and completed the design of 14 data point programs. Its operating cycle has been shortened from more than 2 weeks to 6 hours. Find the correct structure from 2,507 structures. A newly discovered imidazole skeleton, and from the perspective of biogenesis, an alternative evolutionary pathway of aptomy, a type of marine-specific natural product without standing biological activity, alkaloid branch was elucidated. The fifth work was a configuration elucidation technique was investigated. Using a bunch of terpenoid compounds as a flexible structure model molecules, the residue dipole-coupled nuclear magnetic resonance method was used to compare with single crystal data. and it was verified that the RDC method has outstanding advantages in determining the relative configuration of flexible macrocyclic molecules. Moreover, based on millions of data analysis calculations, it was found that for complex flexible molecules, the accuracy of configuration identification can be significantly improved by excluding the key flexible element methylene in the conformational group. On this basis, the absolute configuration of all molecules were determined through QCC-ECD fitting calculations. The sixth work was a double node configuration was investigated. Compound 1, 2, 3 is the new skeletal structure, especially 1 and 2 are structural types of parent nucleus configuration evolution. In the process of determining its configuration, it was found that the chiral carbon linked to the mother nucleus and the hydroxyl group is an independent Shackle double node chiral characteristic structure. This type of structure is rarely found in natural products, especially when discovered simultaneously within the same individual biological species. The accurate identification of its configuration poses a great challenge and is theoretically impossible to determine. Finally, the absolute configuration research method was preliminarily explored through the compilation of DFT-CP3-ECD. In theory, the double node configuration has data copper run. The last work was a nitrogen-containing compound with rare spectroscopy was investigated. A new skeletal molecule is tetravalent with a complex carbon skeleton and multiple heteroatom substitutions was obtained from the coral symbiotic fungi Thalassa variabilis. In the initial structural studies, there was a contradiction between the high resolution mass spectrometry and the general rules of nuclear magnetic resonance. And it was not possible to determine the heteroatom substitution model of the new skeleton fragment marked in red. Through precise DFT NMR calculations, it was finally determined that tadalafil is a nitrogen-doped new skeletal molecules, and the high-resolution mass spectrometry and nuclear magnetic resonance data DFT fitting are highly consistent. The appearance of molecules of the same type in these species indicates that the Tadalafil class has a new skeleton and a special structure molecule.